Hi students, in this video I'm trying to recap series and parallel circuits, and I'll do a couple of examples also just as a part of consolidation. So in the first few slides we are going to see how or what happens to current and voltage or potential difference, which is the other term for voltage, or what happens to them in a series and a parallel circuit. So let's start with a current in a series circuit. So in a series circuit, as you can see here, there is just one loop for the current to flow. So you already know that current flows from the positive to the negative. So the current that is coming out from the positive of the cell goes through this loop, enters the first bulb, leaves the first bulb, enters a second bulb, leaves it, comes out and goes back to the cell. So anywhere you check, the current is going to be the same because there is no other path for the current to flow. So if the current here is 2 amps, wherever I keep an ammeter in the circuit and check, there the current should be 2 amps. So if the current here is 2 amps, it means the current coming out from the cell or the current going back to the cell is 2 amps. So here also it's going to be 2 amps. Here also it's going to be 2 amps. What will the current be here? There also it's going to be 2 amps. Anywhere, it doesn't matter where I'm checking in that loop. Anywhere I keep an ammeter, it is going to show 2 amps. So they can give you a question where they put an ammeter here, they put an ammeter here, they put an ammeter in between the bulbs, and they'll ask you what is the current, what value of current will the ammeter show. Anywhere in a series circuit, the current is going to be the same. So next we are moving on to current in a parallel circuit. A parallel circuit is where the current has a couple of options in its front to flow. Not a couple, it depends on the branches. So here I have taken the simplest parallel circuit possible, and you can see, so two bulbs are connected in parallel. And from where will the current come? So the current, I'm saying the current is flowing from the positive of the cell. And that current, when it reaches this particular junction, what happens? It has now two options to go. Either it can go through the first bulb or it can go through the second bulb. So it's just like I'm driving through the main road and I reach a junction. Then I have two options in front of me to go. Now, say you are in such a situation and you have two options to go. What will you do? You will take when you look at the route, you will take a route which looks like less traffic for you, isn't it? Now here we have two bulbs which are going to offer if the bulbs are similar, they are going to offer the same resistance. So what will happen is, if the current I is coming out of the cell, when it reaches the junction, it splits into two, I1 and I2, in such a way that I is equal to I1 plus I2. Now, will I1 and I2 be equal? It might be, it may not be. It's just like I said before. So, if it is the same bulbs, which means they offer the same resistance, then yes, it will be split equally. Otherwise, as I said before, you will always opt for a road which has less traffic. So less resistance means that branch will have more current flowing through them. More resistance means that branch will have less current flowing through them. But in short, what happens is the current coming out of the junction should be equal to the current entering the junction. And also the current coming from the cell, after all the splitting happens, it will then combine at one point. So here I1 and I2 are going to combine again, and it becomes I like it started here, and it goes back to the cell. So two key things. Current in a series circuit, it stays the same everywhere. Current in a parallel circuit, current splits. It splits in such a way that the current entering a junction is equal to the current leaving the junction. So when you have a parallel circuit, they'll give you, you're able to find out the current through each branch. And if they ask you what is the total current or the current through the battery, you just need to add all the individual currents or all the currents through the individual branches. Okay. So based on what I said before, say if the current here is 6 amps, then what will the current be in the three branches? So you can see that, or we are going to assume that all the three bulbs are similar. So the current when it reaches this junction, that 6 amps has to split. Now how will it split? Since we have three identical bulbs, they are going to split equally. So 6 will be split equally among the three branches. So how much are you going to get? What is 6 divided by 3? 2 amps. So this bulb will also have 2 amps. This bulb will also have 2 amps. 2 plus 2 plus 2, 6. Then what will happen? So the 2 amps is coming here. This 2 amps is coming here. This 2 amps is coming here. Here, the 2 amps are going to meet. So finally, the current that goes back to the cell is going to be again 6 amps. So the current that came from the cell is 6 amps. It got split among the three bulbs equally because the bulbs were having the same resistance, and then they combine together and then go back to the cell. Okay, now let's look at this worksheet, which is about current flowing in series and parallel circuit. So we have to say whether it is true or false what they have said. Now, the information they have given us in question 1 is the ammeter at position 1 reads 2 amps. So the first thing you need to check is what sort of a circuit is this? Is this a series or a parallel circuit? It is a series circuit. And what happens in a series circuit? We just did that a couple of slides before. In a series circuit, the current stays the same. So no matter where I keep the ammeter, everywhere it is going to be, anywhere I keep in that series circuit, if one of them is reading 2 amps, everywhere it's going to be 2 amps. So this ammeter should also read 2 amps. This ammeter should also read 2 amps. Agreed? So what does it tell us? Position 2 reads 1 amp. So that has to be false. Position 2 reads 2 amps. It's true, right? Position 3 reads 1 amp, which is false again. And position 3 reads 2 amps. That is true. Now, let's look at question 2. Bulbs are identical. The ammeter in position 1 reads 2 amps. So this one is reading 2 amps. So the current coming from the cell reads 2 amps, which means the current going back to the cell should also read 2 amps. Then this 2 amps, when it comes here at this junction, that 2 amps have to split. Because we have got identical bulb, how will that 2 amps split? It will split equally. So you will have a 1 amp here and a 1 amp here. Agreed? Now let's look at the true or false. Position 2 reads 1 amp. Position 2 reads 1 amp. Yes, that's true. Position 2 reads 2 amps. That is false. Position 3, which is the other bulb, that also reads 1 amp. True. Position 3 reads 2 amps. False. Position 4, which is here, reads 1 amp. No, it is the current going back, so it should be the same as the current coming from the cell, and which is 2 amps. Okay? Now, continuing with the worksheet, it says ammeter at position 1. So this is going to read 0.6 amps. So this is the current coming from the cell. like before, if current coming from the cell is 0.6 amps, current going back to the cell should also be 0.6 amps, isn't it? So position 5 reads 0.6 amps. Then what is going to happen to this 0.6 amp when it reaches the junction? It has to be split into 3 equally because they are similar bulbs. So 0.6 divided by 3, 0.2 amps, 0.2 amps, and 0.2 amps. Okay? And then the last question on this sheet. The bulbs are identical. They have said again, the ammeter at position 2 reads 0.5 amps and the ammeter at 3 reads 1 amp. What does position 1 read? So in this branch you have 1 amps and in this branch you have 0.5 amps. So these two should combine when it comes here, isn't it? So when you're coming out of it, you will have 1 plus 0.5, which is 1.5 amps. So 1.5 amps should be going back to the cell, which means our ammeter 4 is going to read 1.5 amps. Agreed? And like I have said many times in this video, if the current entering the cell is 1.5 amps, the current leaving the cell should also be 1.5 amps. That's a law of conservation of charge. Okay? Okay, moving on to the next worksheet. It's asking you, is circuit B or circuit C a parallel circuit? If you look at circuit B, there is only one loop. So that can't be a parallel circuit. If you look at circuit C, you can see a branch here and you can see a branch here. So C is a parallel circuit. If ammeter 1 reads 2 amps, okay, I'm just looking where ammeter 1 is. Okay, I'm just going to rub these bits out so that I can write again. So it says ammeter 1 reads 2 amps. What will ammeter 2 read? So what will ammeter 2 read? You guys tell me. So it's 2 amps is coming out of the cell. It goes through the bulb and comes out. It's a series circuit, so everything should stay the same. So ammeter 2 will also read 2 amps. What will happen to the current in circuit A if you add another cell? So when you add another cell, you are doubling the voltage. V equals I times R, which means if V doubles, I will also double. Ohm's law. V is directly proportional to I. How bright would the bulbs in B look compared to the bulb in A? Now, some of you have done the practicals for this. Those who have done the practicals, it would be more clear for them. The more the bulb we are adding in series. When you look at circuit B, there are 2 bulbs compared to circuit A. So the more the bulb you are adding in series, what happens to the resistance? The resistance is increasing. So less current flows, less voltage across the bulb. So the bulb becomes dimmer. Then, if the current in circuit A is 1 amps, what does the ammeter in circuit B read? So in circuit A, we had only one bulb or one resistance. And that time the current was 1 amps. In that case, in circuit B where we have 2 resistances, the resistance has doubled. When the resistance doubles, what happens to the current? Becomes half. So current was initially 1 amps. So now it will become 0.5 amps. So when voltage doubles, current doubles. When resistance doubles, current becomes half. What would ammeters 4 and 5 read? Again, the whole of circuit B is a series circuit. So whatever 3 reads, the same should be read by 4 and 5. Then, how bright would the bulbs in circuit C look compared to the bulbs in circuit B? So, circuit B, you're connecting them in series, which means more resistance. Circuit C, you're connecting them in parallel, which means less resistance. Less resistance means more current is going to flow through them, which means so they are going to be brighter. So I just realized that I skipped to the next slide without completing the questions in the previous one. You can always go back in the video, try that last part, and if you can't figure out, just let me know or ask me. Okay, so till now what we were looking at is current in a series and parallel circuit. Now what we are going to see is voltage or potential difference in a series and parallel circuit. So if I concentrate first on a series circuit, so I have two bulbs or two resistors which is connected in series. So if the main voltage is V, what will happen in a series circuit? The voltage splits. Current stays the same, but the voltage splits. How does a voltage split? It splits in such a way that the total voltage or the total potential difference of the battery or the cell is equal to the voltages across the resistor. So when we said the voltage will be split, again the question is, will they be split equally? As I said before, may be split equally, may not be split equally. It depends on the resistance. So here we have two similar bulbs, means we have two similar resistance. So they will be split equally. Otherwise, more the resistance, whichever resistance is more, the voltage will be more across that. Okay. Now, if the same two bulbs I'm connecting in parallel, so what am I doing here? I'm connecting this bulb across this power supply, and I'm connecting this bulb also across that power supply. So whatever is the main voltage, whatever is the voltage across the battery, whatever is the total voltage, that stays the same. So V1 and V2 will be the same voltage across the bulbs, and that will be equal to the voltage of the power supply or the main voltage or the total voltage in the circuit. Okay. So what happens to voltage or potential difference in a series parallel circuit is the opposite of what happens to current. In a series circuit, current stays the same, voltage is shared. In a parallel circuit, voltage stays the same, current is shared. Now, let's try a few simple examples. Before trying the ones on the board that you can already see, I'm going to put a simple one first, an even more simple one where I'm having two identical bulbs connected in series. So if I have 6 volt here, what did I say just a couple of minutes before happens to the voltage in a series circuit? They will be split, they will be shared. And if the resistances are same, they will be shared equally. So you have 3 volt, you have 3 volt. Okay. Now the questions you get, the resistances or the bulbs are not going to be the same always. So if we look at this example here, it says 3 volt is the voltage or the potential difference across the resistor. 2 volt is the voltage or potential difference across the bulb. So what is the main voltage or the total voltage? What happens in a series circuit? They add up. So 3 plus 2, the total voltage is 5 volt. Okay. Then, now let's look at this one. So here it says it is 9 volt, but we don't know how much it is. But what does it say in this branch? The voltage across that branch is 15 volt. In a parallel circuit, what did I say before? The voltage in each branch is the same as the voltage across the power supply. So if here there is 15 volt, it means in this branch also it should be 15 volt. In this branch also it should be 15 volt. So if you look at the first branch, there's a 9 volt here. Totally it should be 15. So we should have a 6 volt here. So V2 should be 6 volt. Every branch should have the same voltage. The second branch, we already have a 3 volt, totally 15. So V3 has to be 12 volt. Okay. Now, the next question. Find R2 if Vs is 12 volt, I is equal to 0.05 amps, and R1 is 155 ohms. So now, in order to find resistance, what is the equation we have? Ohm's law. Resistance is equal to V over I. So when I'm looking at R2 to find its resistance, I need to know the voltage across R2. I need to know the current flowing through R2. Half of that job is done. We know that the current flowing is 0.05. Since it is a series circuit, everywhere it should be 0.05. So current is 0.05. Now, what about the voltage? Now, we know that the total voltage is 12 volt. So if we can figure out the voltage across this one, then whatever is left from the 12 volt should be the voltage across this one, right? So how will we figure out the voltage across R1? So the voltage across R1, as per our Ohm's law, is the current flowing through R1 times the resistance of R1. The current flowing through R1 is 0.05 amps and the resistance is 155. So what is 0.05 times 155? Thing is, when I was planning to do this, I didn't keep my calculator ready, and at the moment I don't think my brain works to do this in my mind. So 155 times 0.05, isn't it? So 7.75 is the voltage across R1. So what will be the voltage across R2? Total is 12. 12 minus 7.75. That should be, how much is 12 minus 7.75? 4.25. Yeah. Sorry. Now, what is the last thing we have to do? We have to find R2, isn't it? R2 is the voltage across R2, which is 4.25, divided by the current that is flowing through R2, which is 0.05. So 4.25 divided by 0.05. So the resistance is 85 ohms. Okay. So what you need to figure out. So to find resistance, if I go through the question again, to find resistance, I needed to know the voltage and current flowing through the resistor. From the question, I had the current flowing through the resistor, but I didn't have the voltage. So using the current, what I did was, using the current, I figured out the voltage across the other resistor. And since I had the main voltage and I know that voltage is shared, I took away whatever whatever came across R1, and the remainder comes across R2. So now I have the voltage and the current, and using that I have figured out the resistance. And the last thing is a very common question they ask: what happens to the bulb when you connect more and more of them in series? And again, as I said before, those who have already done the practicals, it was very visual to you. So what will happen when we are connecting more and more bulbs in series? The bulbs will become dimmer and dimmer. Why are the bulbs becoming dimmer and dimmer? Because more the bulbs means more the resistance, which means less current is flowing through the circuit. Okay, and also you can say because you're connecting more and more bulbs in series, the voltage across each one will also decrease. So that's it about series and parallel circuit. Hope have done some justice to the topic, and using this you should, I'm hoping that you will be able to do the questions on series and parallel circuits.